Welcome to the Orthogonal Bet, where we explore the weird and wonderful ideas that shape our world. It's a cabinet of curiosities for the ears and the mind. I'm your host, Samuel Arbesman, complexity scientist, author, and scientist in residence at Lux Capital. In this episode, I had the pleasure to speak with Daniel Temkin. Daniel is a writer and artist who works in the digital art space and has been creating strange and provocative programming languages for years. These esoteric languages, or Esolangs, can help to explore the limits and breadth of what programming and code can be. Daniel recently released a book collecting languages he created called 44 Esolangs, and it is wild and fascinating. Daniel and I had a chance to explore the nature of Esolangs, the benefits of playful constraints, how to think about programming languages more broadly, code poetry, the balance between the unforgiving and human properties of code, and even how he was able to turn these experiments and projects into a book. This conversation was fascinating, and I had a great time speaking with Daniel. Let's jump in. So, Daniel, great to be chatting with you, and welcome to the Orthogonal Bet.
Thank you.
Yeah, this is exciting. There's a lot of directions I want to go. I think maybe the best place to start is just if you can explain what are esoteric languages and what drew you to these.
Yeah. So, I wrote a blog, Esoteric Codes, for about 10 years to try to answer that question of what are these languages? Why are people making these languages? What are these for? So I started experimenting with programming languages that are deliberately impractical starting around 2007, 2008. And at that time, most of the writing about esoteric languages, or Esolangs as they're called, were very technical. So you'd look up at an Esolang on the wiki, and there'd be a description like, oh, this is a 3-tape Minsky machine. It's like, okay, well, that's interesting. If you can kind of put together what that is. What is this about? Why did you make this language? So I started Esoteric Codes to interview people who make these languages and ask them sort of more in plain language, what is this language about? Why did you make this? What draws you to these languages? Now, my answer to that really begins with a couple of papers that I read about Minesweeper. So someone named Richard Kay, a professor, wrote a couple of papers showing that Minesweeper is Turing complete. And what that means is if you have an infinite board of Minesweeper, you can build a computer within it, and it can carry out any algorithm that you might write in a language like C++. It was sort of just amazing to me. It speaks to the computer as a simulation device, something where once you have a system like Minesweeper, you can build almost anything within it.
I was going to say, and also like the interesting thing about Turing completeness is, and we can maybe discuss this as well, is like just the fact that once you kind of reach this certain level of complexity, like this threshold, suddenly everything is effectively equivalent. Now, of course, the details matter, and there's a lot of nuance in there. And then, of course, some things are still easier to do. But yeah, I've always just found that kind of like once you kind of reach this boundary, then everything is sort of out there. Like any algorithm you can think of, you can effectively do. Anyway, I'll just let you go.
Yeah. I mean, obviously, writing a program in Minesweeper has a very different experience than writing it in C++.
One would assume.
Your mental model of what's happening is completely different. But it just sort of blew me away that this thing was possible. And at the time, as an artist, I was working a lot in glitch art of sort of deliberately breaking images to see what sort of visual results we get from them and sort of interfering with the process of representation. And carrying that into the space of programming languages really interested me. But the language that really excited me at the beginning is a language called Pete, spelled P-I-E-T. And Pete is a language, it's named for Pete Mondrian, and it's written as images. And it's the change in color from a group of pixels called a codal to the next that determine commands. And so what was sort of exciting about this for me is that, David Morgan-Marr created this system. He created rules about how these images are read as code. And he had a certain aesthetic in mind. Obviously, he was thinking about Mondrian to some extent, since that's who he named it for. But what happens is you put this out in the world and other people experiment with it and they find their own style within it. They find their own way to construct algorithms. They find their own sort of personal visual style within Pete that still looks like Pete, but doesn't look like the stuff that David would have made or that I would make in it. So there are people who make Pete programs that look like digital images where the Pete program is entirely hidden within it. There's even a Pete ready-made. Someone saw a painting that looked like it might run as a Pete program, took a picture of it, converted it to more pure Pete colors, and ran it. And it turns out it's a program that actually takes input and converts it and outputs it, which was, a program that was not created intentionally, but is a working Pete program.
Oh, wow.
And so this reminded me a lot of constraint-based writing and art. especially work from the Oulipo movement of the 50s and 60s, where writers who called themselves the rats who build their own mazes would construct these constraint sets, like write a novel without using the letter E in French.
That was, I think, I guess the English equivalent, the English translation was like The Disappearance or something like that. Was that the book that they ended up writing? I can't remember.
Yeah. That's close to the name in French, but
I'm saying obviously that would not fly because there's E's in Disappearance, but like whatever it was, I don't actually know.
They call it a void.
Okay, there you go.
In English. Yeah, it's by Georges Perec, who has 4 E's in his name. But I mean, you have to imagine the translator. I mean, this is quite a long book, and someone had to translate this entire thing from French into English.
Not only was it hard to write the book in French, then there's like the additional task of like translating it in a way that also preserved the constraint. Oh, that's kind of wild.
Yeah. So there's this kind of play. It's the Esolanger who makes the language has certain constraints that are sort of built into the language. This is how you make a language. And then there are the ESO programmers who come to it and explore the space that the Esolanger made and make their own discoveries about the languages. And this was very exciting to me because it's a kind of collaboration that's very different from other artistic collaborations. Making a programming language, it's like making a whole world. And you really don't know what other people are going to bring to it. So that was part of what really excited me about it at the beginning.
You said like creating a whole world. It's almost like creating a set, like a tool set, and saying, okay, here's a tool set. This is kind of the way I envision you using the tools, but you can really go off and use the tools in whatever way you want. Is that, I mean, the similar, like that kind of idea around sort of the programmer, the creator, the actual user of the language, were those when you were interviewing a lot of these designers, like programming designers or language designers, did they also have the same kinds of reasons that they were drawn to Esolangs?
They really had all different reasons. A lot of times it starts with an idea of, there's one concept in code. How far can I push this and still have a working language, or will it be a working language when I sort of go all the way with this? There are some people who really are drawn to what I call the sort of technical wizardry that you're not really allowed to do in mainstream code that much. We're sort of taught to write code in this very sort of neutral voice without having a lot of personal expressiveness in the text of code itself, and to write code that other people can understand and that we'll understand when we come back to it a year later, really prioritizing clarity. But, you create a language like Brainfuck where everything is written in just 8 commands, all represented with punctuation marks. And there's no way to write really neutral code in that. And you have to make all kinds of arbitrary decisions to do the most basic things. There are, the number 34, there's nothing built into Brainfuck that lets you write that. You can't use the numeral 3 or the numeral 4. You have to sort of move through memory to the memory cell that you want to have that number. And then you can have 34 plus signs to add them one by one so you get to that number. Or you can create these algorithms where you're moving back and forth between memory cells to basically create multiplication, or do these tricky things where you're going past 0. Because if you go to 255 and you add 1, it goes to 0. So sometimes you can sort of loop in such a way that it's passing 0 many times. And so people have to sort of come up with their own approach to almost everything. And that can be an exciting space to explore and lets them kind of show off in a way that you're not really allowed to do in code that you might write in Python for a job.
Fair enough.
There are a lot of Esolangers who created languages that create a space for that sort of experimentation that doesn't happen as much in mainstream code.
And it also reminds me a little bit of like other efforts to kind of take programming and like stretch it beyond sort of the boundaries of like code golf, or like the whole demo scene. I don't know if you want to talk about those and kind of like the similarities and differences between some of those communities. They're all working within constraints in different sorts of ways.
Yeah, what's interesting about that, the group of languages like Brainfuck that function in that way are often called Turing tar pits. And what's funny, the examples he just brought up, I mean, code golf is all about writing code with the fewest number of characters. So it's the minimalism of it, which gives you the excuse to work away from clarity and work in that space of sort of technical wizardry and like, how can I get this one character shorter? And it's the same thing with demos, because demos are often supposed to be under a certain size. And it's sort of like, how much can you pack into that size? How much visual and auditory expression can you pack into that? And the Turing tar pits often work through minimalism as well. Brainfuck is a very minimal language. It was inspired in part by False, a language that had come out earlier that year, which had a 1K compiler and was a very minimal language that had a lot of features. almost everything in it was written with as one character. Brainfuck, I think the original compiler was under a quarter of that size, so under 256 bytes. So it's sort of the minimalism leads to a sort of maximalism of code.
It's kind of like it's sort of like the inverse, right? It's like the language itself is very spare as opposed to the code itself. And as a result, the code kind of balloons in order to actually be able to do anything moderately useful.
Yeah, exactly. The mental model you have to have of the code is so simple, but every task becomes this sort of arduous thing where, if you want to copy a string from one place to another, which might be one line of code in most languages, in Brainfuck, it's a series of memory cells that hold numbers that translate into characters, and you have to go through them and copy them individually. It gets very complicated.
So you mentioned the kind of the delightful aspect of the creator of a language kind of being surprised by the different use cases and the different ways it's being used. Were there any language designers that you spoke with that almost felt the opposite? Like they were like, oh no, I have this very clear sense of what the language should be doing. And all of you users and all of you programmers, you're all disappointing me and going off in directions I really didn't want. Like, was there any of that, or was there really this sense of delight?
Actually, I have a good example of that. So there's a dialect of JavaScript that looks like Brainfuck because it's all written in punctuation. So this is the work of Martin Kleppe, and it came out of a conversation on Twitter where, collectively a few people sort of discovered that you could do everything that you can write in JavaScript, you can translate into 6 punctuation signs. Wow. And it's almost like a little language hidden in JavaScript that was not created intentionally, but exists. Eventually, Martin created a transpiler from JavaScript into this into JSFuck. But this was something that was an experiment. It was really sort of about that expressiveness. But what ended up happening was some malware writers realized that a lot of the systems that scan for malicious JavaScript don't understand JSFuck. So for a while, people were hiding stuff. I mean, now they check for that. But I think that's one example that was a negative. But for the most part, people are delighted by the surprise of people taking their piece in a different direction. I actually have a dialect of JavaScript myself called Fatfinger, which is essentially if you have a script tag, if you include in my library and you have a script tag with any misspelling of JavaScript, it goes into Fatfinger mode. And what happens is you can spell everything wrong. It looks like regular JavaScript, but you can spell things wrong everywhere. Your variables don't have to have a consistent name. It can be X and it'll be Y next time. And it just looks for the closest thing in scope that it recognizes and it translates it into that, basically. So for me, this was a piece that was really sort of about the compulsiveness of code and bringing back the human aspect and like, okay, let's not try to get everything perfect. Let's kind of write some sloppy JavaScript, which is kind of what JavaScript is for, in my opinion.
Quick and dirty, yeah.
Quick and dirty, yeah. And don't bother trying to clean things up. Just leave it all sort of messy. Just do it in Fatfinger and it'll be good enough. I very clearly stated that, like, don't use this as the spell check for JavaScript. That's
I'm sure. Well, I'm sure your programs often have like unanticipated consequences when it's kind of trying to find like the nearest thing within scope. It could go off ways you don't expect.
That's right. But so I was very concerned that people would use it as a spell check and use it sort of, which was not the experience I wanted people to have of it. But what ended up happening instead is that a code poet realized that instead of having typos, you could intentionally swap one word for another. And you could even use a word that seems very far, like the word daughter for the word navigator. And very often it'll map to that. So he created a list of words, which he called fat dactyls, of sort of alternatives you can use for things in the DOM or JavaScript keywords and these variations that'll work in Fatfinger so that you could write code poetry that would read as a poem but still run as JavaScript in that Fatfinger mode. So it's this very deliberate use of it, which is very different from the kind of quick and sloppy version I was expecting. I found that very exciting. And that's really that's that collaborative aspect that I think is pretty rare in other parts of digital art or not as common as it should be. That is very much easier to tap into in the Esolang world.
And maybe you can speak also just about like the size or the nature or the breadth of the Esolang community. And then also, I mean, you mentioned a code poet. I would love to hear a little bit more about that. But but maybe first just kind of give me a sense of, what is this? Like the Esolang community, I imagine, is pretty broad and there's kind of different people coming at it for different reasons. And there's kind of like the playful constraint kind of stuff you're talking about. But I imagine some might be coming more from the kind of like engineering game of like, what can I do? Like, what are the ways I can kind of like stretch the system versus maybe people coming more from the art world. Yeah, what does this community really look like? And is it also, I assume it's a pretty small community.
Yes. I think there are many programmers who are aware of a couple of esoteric languages. They might not know the word Esolang, but they've heard of Bfunge or they've heard of brainfuck, and they sort of know there are these languages that are like that as a kind of programmatic play. But in terms of people who contribute kind of more consistently to Esolangs, nowadays there are more people coming from an art or a poetry background, people who are digital poets who decide to create their own language. I'll get back to the aesthetics of code a little bit,
Sure,
a little bit later, because but just to give an example of this. So there was a Esolang called Shakespeare that's created, I think, around 2003. And it's a language that reads as a Shakespearean play, but it's kind of an annoying language, to be honest. The characters are basically just sort of insulting each other. Like if they use a positive adjective, it adds one, and if they use a negative one, it subtracts one. But it's sort of more fun to use all the insults, so there's a lot of negative numbers.
Amazing.
But the thing about Shakespeare, so Shakespeare and Pete are languages that are multi-coding, and what that means is they can be read in two different ways that impact each other. And it's the way they impact each other that sort of makes them interesting. So in Pete, it's both an image and it's code. And so when you're creating it, you're trying to create a working program, but you probably have some idea of what you're going for the image, or where how it looks as an image is obviously impacting how you're drawing.
Right. It's obviously some sort of consideration as you're thinking about it, because that's inherent in the language itself.
Yeah. Pete is a great multi-coding language because it has the code often looks like Pete, but also you can bring you can wander very far from previous Pete programs and bring it in new directions. So that's what really makes it exciting to work in. The thing about Shakespeare is that pretty much every program reads like a Shakespeare program.
Okay.
It's a big long list of insults. It's not really that interesting. Once you've seen one, you sort of get the point of all of them. But what's happened is more digital poets were inspired by Shakespeare to say, okay, how would I want to make an Esolang that's actually for poets? And there was a project called Esopo, which is a combination of the words Ulipo and Esolang, which is a series of languages for poets. I think it's by Will Hicks. I think he only completed a couple of them. But one of them is ash paper. And the way you encode things is by capitalization in the middle of the word, rhyme, meter to some extent, indentation. So it's more the tools that poets actually work with. And now you have much more freedom to write a poem that how it runs as a program can relate to how it's written as text. And so you get these more interesting relationships in an area of exploration that's much larger than you would get in Shakespeare. And there's another language called Inverse, which is a shader-based program. So it produces images and video. And that one, each program has a word table. So you can map the commands in Inverse to your own vocabulary. So you have a set of vocabulary for your program. And so that gives even more freedom. And so there's a number of other languages that have come out since then that sort of work along the same lines. But a lot of them were inspired originally by Shakespeare. It's like Shakespeare opened the door to this whole other area of exploration. But okay, so these are digital artists and poets, right? And so they're coming in with a certain sort of point of view. But if you go back to the beginnings of Esolangs, the first people who made these languages, they're programmers, they're hacker hobbyists. They're not interested in contemporary art. They're certainly not reacting to it in the way that they're designing their languages, but they are a sort of counter aesthetic to code, to mainstream code.
Yeah.
So what's sort of interesting is what is the aesthetic of mainstream code? What is it after, and how do Esolangs differ from that? And I think of Dijkstra as one of the great sort of aesthetes who really sort of set much of the aesthetics of code.
He was very opinionated on those kinds of things.
Yeah, there's some great quotes in your book, in Magic of Code. I think he called Fortran an infantile disorder.
I feel like that was definitely one of the language. I don't know which one, but he was very disparaging towards basically every language.
Yeah, there's something about being mentally mutilated. I think that was Basic. Basic makes programs. Yeah, I love that. It's so like delightfully bitchy, and it really sounds like Dijkstra. But Dijkstra had a document he wrote in the early 70s called The Humble Programmer, and that really defines what most of us are taught as good code practices. And it's the same thing if you're working in a corporate environment or in creative code. You're sort of taught basically the same rules that Dijkstra set out. And they are having neutral voice in code, not showing off too much. That this is the thing that he goes back to over and over again in Humble Programmer, writing things as clearly as possible. So why is he so insistent on this? Well, the essay is really about the professionalization of code as a programming, as a practice. And the early programmers working in the era when computer cycles were expensive and you had to make things as efficient as possible would often, figure out how to shave off a little bit of their program to get it to run a little bit faster. And this was really necessary at the expense of readability and having the code understandable by other people. When we're getting into the 70s and code becomes a bit more democratized and a little bit easier for other people to understand, there's also a de-skilling that goes along with that as well. And here I'm thinking of this great essay, Sorcery and Source Codes by Wendy Chun, where she talks about this quite a bit. But not all the programmers were happy about no longer being sort of the technical wizards. And they...
like keepers of this like obscure lore that no one else can fully understand.
Yeah. But also it's fun to write code that way.
Right.
So, Dijkstra saying, knock it off, everybody. Let's, we have to be professionals now. And the programmers some of them were saying, no, I sort of like the way that we used to do it. And so that's where this technical wizardry idea comes back in. They create their own spaces, like demos, like Code Golf, like Esolangs, where they can kind of show off this sort of technical wizardry and work in this way that's challenging to themselves. And they're not working as much in that sort of corporate model. So, I think of Esolangers as sort of the less humble programmers, those who, whether they're doing it for showing off technical skills or they're doing it just to sort of express themselves in the text of code, they are breaking very clearly from from these basic ideas. So that's one aspect of mainstream code. But in general, I think of Esolangs as sort of this counterforce against these kind of received ideas of computing.
And so then code poetry is really just kind of like a superset of some of these kinds of things. Like sometimes it can be done in kind of more traditional languages, but kind of pushing against those boundaries. Other times it can be using, like either creating Esolangs that allow you to do some of these kinds of playful, poetic nature. And would that be a fair way to describe code? Like code poetry is sort of, it's larger than Esolangs, but it also definitely has a certain degree of overlap in terms of some of the practitioners of code poetry or involved in that kind of thing?
Yeah. It's a little tricky because people don't use these terms very consistently.
Yeah, and that's fair.
But there's what we think of as code art and code poetry, which I think the difference really just comes down to whether they think of themselves as artists or poets, are basically work where you have to read the text of code to fully understand the piece. There's a great book of code poetry by Chris Kerr and Daniel Holden. I think it's just called Code Poetry. One of the things that they do, there's a piece that makes fun of the idea of elegance in code, which is definitely sort of an oversold idea. And so it draws the Fibonacci golden spiral thing. You're not talking about like the golden ratio that the spiral comes from, but the code that writes it is JavaScript, but it's full of like conspiracy theories and chemtrail stuff.
Like elegance can somehow arise from very inelegant and sort of conspiratorial and paranoid mentalities, which is kind of a surprising sort of a non-intuitive, or basically the opposite of what you might expect. Is that kind of what it's trying to say?
Yeah. But I also think that elegance is something sort of mystical in code. Like what really is elegance? It's something that we're sort of taught is sort of a good thing, but that really seems to come from a mathematician's aesthetic.
Oh, interesting.
How much it belongs in code is sort of arguable. And so I think that part of the conspiracy is this idea of elegance itself. But I think you can...
And also sometimes like searching for elegance or demanding elegance often means that you're oversimplifying the world, which is not so different from conspiratorial mindset where like you're trying to find connections everywhere. And guess what? The world is just kind of messy and that's okay. And it's not elegant. So elegance actually, might have a certain kind of like perversity there in terms of kind of searching for it everywhere. Mm-hmm. So this might be a good point. I feel like we've like talked around about Esolangs and things like that, and kind of talked around some of the languages that you've created. I would love to, if you could, so you have this book that is brand new, 44 Esolangs. There it is.
I just got my author's copy. So
yeah. I would love to hear. I mean, it sounds like you've been making these languages for a long time, and then maybe at a certain point decided that there was a book length kind of project there. Maybe not. And I would love to kind of hear about like the goal and like the nature of the project of these 44 languages?
Yes. So these are languages that I've made since 2009 or so, and so it's a collection of languages. So I'm a visual artist also. I have an interactive project up right now at Museum of the Moving Image, which is also sort of playing off the idea of human irrationality versus systems. It generates dither patterns.
Oh, interesting. Okay.
And so this is something where I love the dithering algorithm because it uses elementary school math. Basically, it's all like subtracting and rounding basically.
Yeah.
But it creates these patterns that feel irrational to us because we're irrational human beings, and even a little bit of complexity and logic is sort of beyond what we can really sort of calculate.
Our minds are pretty simple in terms of what we can understand.
Yes, our minds are very simple. This is the experience I have as a programmer is sort of my own sort of irrational understanding of logic, of running into this logical system that's really unforgiving. And so the dither piece is a way of showing this visually for people who are not programmers. But then it's like I'm working on the same sort of ideas in code by creating these programming languages. And the book was my attempt to open up these languages to a less technical audience, and also sort of to collect them all together in a way that they can be showcased. Because how am I going to show programming languages in an institution? A book seems like the most approachable way to sort of treat them as a group instead of like, well, here's like a random interpreter I have on a web page somewhere, and here's like a GitHub project for people to look at. But here, okay, let's consider all these things together. So the starting place for me with this book is what is a programming language, and how can we sort of unravel that definition? So to the question of what is like, what's the definition of a programming language? A lot of the project of this book is to sort of undefine programming languages to some extent, or to kind of challenge the
like how subvert like certain assumptions that we have of like, oh, all languages need to look like this, and then you're like, oh, guess what? Here's an exception. Is that kind of the idea, to kind of give you a sort of more capacious sense of what programming languages can be?
And I want to show sort of the artistic possibilities of creating Esolangs. I'm hoping this inspires other people to make languages, and also to encourage people to code who perhaps felt intimidated by it. I think that Esolang still exists in this space where they're still described mostly in these sort of technical terms that are sort of off-putting to a lot of people. Sure. And so, the challenge of the book is how do I present this without going down that really technical route? What is code but a kind of performance? So I looked at how the Fluxus and conceptual artists dealt with the same problem of representing performances to people who are not there to see the performance. And so I modeled this a lot on a collection of Vito Conchi's work, of his performance work, collected in Diary of a Body, where he had these sort of proposed performances, and then he'd have documentation of some of them that were carried out. And then also I looked quite a bit at Grapefruit, Yoko Ono's book, which are these sort of delightful performance scores that mostly are meant to sort of run in your head, but they have this great poetry to them. There's one about taking balloons and skinning them and then releasing them into the sky. So it's the balloon without the balloon. And so it's these very short, simple prompts that are easy to understand. And then some, in the Vito Conchi model, I've actually turned into working programming languages. Some I've defined in a way that really can't run on conventional machines, or I'm sort of allowing readers to develop their own version of it if they want.
Yeah, I was going to ask. So some of these languages have not actually been implemented. Is that what you're saying?
Yes.
Okay.
Yeah.
Because there was one, I think, where it was like the inverse of C, where it was like anything that's like, and I was like, how is this working? And so that makes a little bit more sense now.
So I have one that is an Esolang of unmediated thought, pure affect without words. To articulate code renders it inert. Only the unreified holds meaning. So its code is something that not only it's something, as soon as you translate it into words, it's no longer code in this language.
All right. So it's much more of like a thought experiment and like provocation rather than like, oh, like by the way, go to this link on GitHub and you can get the compiler.
Yeah. So the first half of the book are the prompts. At that point, if you read the book in order, you don't know which of the prompts are actually implemented as languages and which aren't. And I think for some of them it's kind of a surprise of whether they're actually they actually have working compilers or not. I leave that to the second half where I show how these function as working languages. And often, the sort of hand-wavy initial sort of prompt lead to some really sort of surprising outcomes when you actually put it together as a language. And so that's really what I deal with in the second half of the book.
I love it. And that also speaks to, we were talking about sort of like the unforgiving nature of code. I think you mentioned that word versus kind of human natural language, which is a lot more ambiguous and messy, and so it allows you to kind of conjure up images in other people's minds that maybe are not as precise or kind of different. But you also kind of are hinting at the fact that like even when you create a prompt that sounds really human and vague, in the act of trying to figure out what that would look like as a language, you bump up against that unforgiving nature, but you actually also end up learning new things and trying to like articulate what that kind of thing is. And I feel like there's something really interesting there. Maybe not necessarily about Esolangs, but also kind of about programming more general, of like that programming is really at that intersection of like the human and the unforgiving nature of the machine.
Yeah, I think that's exactly right. And that's the space that I really like to play in, because there's nothing that exposes human irrationality like running us up against a system that is unforgiving in that way. When you define a programming language, the language tells you what the code is, right? And that's sort of obvious. It's like Python code does not look like Perl code. It's only the language definition that really tells you what is code in that language. But the language also gives you an abstract version of the machine, which are sort of like the possible things you can do in the language. And that's sort of what creates the mental model that you have to use to sort of think through the language. If you are working in C#, you might think about objects that interact in a certain way. But then if you think about it, that's Turing complete, of course. And the language forth is Turing complete. But if you're thinking in terms of forth, you're thinking in terms of the stack, moving things around the stack to manipulate things. Your actual steps you'll do to carry out the algorithm will be very different in these two different languages. So it's the programming language, defines the other two things. It tells you what the computer is, and it tells you what the code is. And so many languages in this book use that relationship to remove it from conventional computing. And sometimes, like that unreified language, it removes it completely from our physical computer. And that's not always the case. It's sort of like the computer as simulation device. Can it simulate the abstract machine that the programming language asked for? And so they all have sort of different relationships to that. And so the idea is to sort of extend these concepts of code and programming language as far as I can take them.
Related to that, and some of these Esolangs, even though they're very strange and probably very frustrating to write code in, some of the ones you develop in some of these other Esolangs are also in some ways almost like robust to error, or in the sense of like you can basically give them anything and it will run as or not necessarily anything, but like there's a much broader space versus a lot of traditional programming languages. And if I just kind of, bang on a keyboard and try to run that, that's not Python code. That's nothing. But like with like brainfuck, for example, if I just, do a whole bunch of random things of like those 8 characters, that will be a program. Like it might not be necessarily be anything that I want. And maybe I'm not quite correct here, but I feel like there's like some of the Esolangs, because they're so strange, sometimes are a little bit more forgiving. Maybe I'm not articulating this, or maybe I'm entirely wrong, but I'd love to kind of hear your thoughts on that kind of interesting balance there.
Yeah, no, I think that's right. I mean, with brainfuck, as long as you have the same number of left brackets and right brackets.
Oh, wait, I think yeah.
Other than that, I think
yeah.
But there's a lot of, so there's a number of languages in my book that are languages that people do not code in intentionally at all. They're really only meant to have accidental programs. So sorry, I'm talking about like really the most pretentious languages in my book mostly, but
that's just fine.
But that's fine. We'll get to some of the gritty ones a little bit later. But I have to bring up this one language. I have a language whose name changes regularly, because the name of the language is always the first sentence of the definition of programming language from
Wikipedia.
Wikipedia, yeah.
I saw this one.
And so I created this in 2014. And so there's a big long list of formerly known as. But what happens is, this is not a Turing complete language. There's only one possible program for this language, which is that sentence itself, including the period, the whole thing. That is the program. And when you run that program, it outputs itself. It prints its own source code to the screen. So it might sound like, okay, this is a language that does almost nothing. I've implemented this as a bookmarklet that you can run on web pages. And what happens is it wipes out everything else from the page except for that one sentence. So you can just kind of think about that sentence. So, first of all, it is meant a little bit to embarrass people who are just taking the Wikipedia definition and putting this up of like, this is what a programming language is. Okay. But mostly it's sort of like, okay, let's just ponder the sentence. What does this say and what does this mean? When the reality is this language almost always is an exception to that sentence, to how we think about programming languages.
Okay, I love that.
So it's, yeah, so this is, and one of the things that I was not expecting with this is that a number of people have implemented interpreters for this. And I've sort of realized that a lot of them are high school kids who are sort of like, okay, I want to make a programming language, or I want to make an interpreter for the first time. And it's like, oh, here's one that's pretty easy to do. Let me try that first. And so, like, I think that's great. It's like the first step towards learning how to write sort of more complex parsers. This is obviously a very simple one.
Right.
So people have written interpreters for it, but nobody, as far as I know, has intentionally written a program in this language. But I also have, I have languages that are meant to be sort of run on other human texts that are not normally thought of as code. And it's the relationship between certain letters become the code in it, and it will do something. It'll output something at the end, but again, not written intentionally.
Okay. Yeah. And so one of the reasons I was just struck by some of these like more forgiving languages is also like I very interested in kind of the realm of like evolutionary computation and evolving computer programs. And of course, if you're evolving like a traditional computer program, like mutating it and recombining it, you're going to break it most of the time. And so you often then have to create certain types of representations for programs that are a little bit more forgiving. And I feel like in some ways, these kinds of things work a little bit better. And I believe actually someone even made some modified version of brainfuck and then used that for evolutionary computation purposes and things like that. And so even though we think of Esolangs as provocations or art or kind of technical challenges, we're finding somewhat of a useful case for them, which is kind of intriguing. But then there's also even just the educational component of, okay, if all these things are programming languages, then people can then figure out how to build, parsers and interpreters very easily with some of the more kind of simple ones. And I guess related to that, because you've released these languages over a course of many, I guess like 15 years or so, what has been the response or take up of different languages?
Yeah. It's always a surprise to me which languages get a response from people. I have a language called Folders, which, as far as I know, this is the one that's sort of best known of mine. And it was inspired by an earlier Esolang called Whitespace, which was written with space, tab, and return, ignoring everything else. And Whitespace was great because a language like C doesn't care what kind of white space you use between words. It'll treat a return the same way as a tab. So you can hide a white space program in the spaces around C. And so I thought that was exciting. But I was thinking, what's more empty? What sort of represents sort of a lack of content more than tab space and return, which is still, these are still characters. And I was like, well, the empty folder, when we have an empty folder, it has nothing but other empty folders inside of it. It just looks like junk. It's stuff that it doesn't have any reason to exist. So it's like, well, okay, well, what if I made my language entirely out of this? So essentially what happens is a command folder, whatever the first folder is alphabetically, the number of folders within that determine what command it is. And then the command will have a second folder that'll take it'll take its arguments, or it might take child commands and so on. So you could reorganize your hard drive to be a folders program if you wanted to. And I originally made folders just for Windows, the original version, because in Windows, folders supposedly take up 0 bytes. Obviously, they do take up space if you create a lot of folders, but it won't tell you what they are. So the conceit was, now we have infinite file storage because we can have all of our data and programs just represented as folders. And it's almost like a parallel file system alongside Windows that's just kind of doing its own thing.
It's fantastic.
And then someone wrote a Python interpreter for folders at some point, and that got some attention and so on. But I also liked the idea of sort of try to dematerialize code, make the code seem to disappear. And for me, I guess I was thinking about that a lot, because the idea of what actually is the language? Is the language a definition? Is the language a reference compiler that shows how it should be compiled? Is it a set of sample programs? How is it defined? And so playing off the sort of dematerialized aspect of the language, I like sort of reflecting that by making a language that felt as empty as possible.
Do you have any particular favorites of the language? And I imagine all the languages are your favorites. But are there any ones that kind of stand out within the book?
Oh, yeah, it changes all the time. Let me pull a language or two. Oh, yeah. So the book starts with language 0. Language 1, just to give an idea of sort of the difference between the prompt and the realization of that prompt. Language 1, a language that better reflects the power dynamic between programmer and machine. Each line of code pleads with an interpreter god to act. The gods ask not only for clarity, but for humility and sincerity of desire. So that's okay. You might be picturing something. But what the code actually looks like, and this is one that's fully implemented, so you can write your production code in this if you want. Here's a line of code in it. Lord Zeus, master of storms, father of the gods, defender of cities, defender of homes, defender of the travelers and of those far from home. I beg you to create a function called print beer inside loop for parameter n that prints n, comma, beer string, comma, in quotes, on the wall.
That's amazing.
So when I was working on this language, I was thinking a lot about sort of the pettiness and the sort of, I mean, it sounds ridiculous to ask Zeus for this big long line of these. I mean, how could any of our desires not seem petty to the gods, right? But what I'm saying about the power dynamic in the prompt for this is that we command the machine as if it's sort of ours to command and we're sort of the master of it. But we're really not, because how often does it actually do what we wanted? I forget the exact quote, but to paraphrase Ellen Allman, any program of significant size is going to have bugs. And of course, the computer does what we say, not what we want. And so this was sort of an attempt to sort of correct that power dynamic. It's not so much commanding as praying for the thing that we desire, and with the hope that the computer is going to carry it out the way that we want. Now, Olympus has very specific requirements. The reason I have all these sort of epithets for Zeus at the beginning is because based on how complex the command is I'm asking Zeus for, I have to give him the right amount of praise. If I don't give him enough praise and I ask for something too complicated, he'll just ignore it. And if he's really irritated, he'll ignore all the requests of Zeus for the rest of the program. And it's important because Zeus is the strategist, and so you have to call on Zeus quite a lot. Athena will also do pretty much anything that Zeus will do. But then, for some of the other gods, they don't really have so much of a backup. If we want to deal with data storage, we talk to Mnemosyne, the mistress of memory. If we want to close a block of code, we call on Hades to collect the souls of any variables that remain.
It's like the junk collection or whatever, or garbage collection.
Garbage collection, yeah, exactly.
Garbage collection, but for souls of variables. I love that.
And also, you can't call on any god too many times in a row. You have to sort of spread it out, which means you have to organize your program around the gods instead of sort of the normal logic. So we're basically describing the program all out of order. To get it to work.
Wild. I love it. When you were working with your MIT Press to get this book published, what was that process? I mean, just in terms of like saying, okay, I'm going to write a book about computer code, about languages. I'm just going to be describing them, but they're kind of works of art. Like, was this something where they're like, oh yeah, immediately we're on board, this is amazing? Or was there a lot of convincing? Because it's a very qualitatively different kind of. I'm so excited that it exists, but it feels very different from lots of other books.
Yeah, it feels very unlikely that this book came together and exists in a physical form. I'm still a little bit in shock that this has happened. But it really started with conversations with Nick Montfort, who is one of the editors of the hard copy series, along with Mary Flanagan. And I've known Nick for a long time. We kind of connected over retro computing in the early 2010s. So he's been aware of my work for a while. And it turned out they were starting this new series that was going to be more about computer art and looking at the output of computer art. And so he's been a supporter of mine. But it had to go through, because MIT Press is an academic publisher, it did have to go through academic review. So two professors, I don't know who they are, looked over the book over the summer. And because it's an art book, this wasn't sample chapters. I had to write the whole thing so that they could sort of decide the artistic merit of it, along with whether the book is going to make sense to other people and so on. And I'm very thankful to my reviewers, because they had a lot of good suggestions about organization and which things were more clear than others and so on. But MIT Press has been very supportive. Once it got past that academic review, they were sort of on board that we're going to go ahead with this book. And they had to deal with all my silly questions as a first time author, and this sort of unusual. There's a lot of Unicode in this book. There's a lot of stuff that was not so easy to print. So there were many conversations about how to get this to work on the page.
Oh, it's amazing. I'm glad that it was able to actually become a thing that actually exists, because right, it does feel very unlikely. That's amazing. I guess maybe a good last question would be, I mean, so other than Esolangs, like what are your favorite kind of working language, like programming languages that you actually use on a regular basis?
Yeah, that's a good question. So I've sort of gotten in the habit of writing most of my interpreters for these languages in Python or JavaScript because they're the most widely used and it makes it the most accessible to more people, which I know is a very boring list of languages.
No, and that's
so
fine.
amazing.
Yeah, it's just, and yeah, it's not surprising either. Right, because they're very widely used. Yeah.
Yes, JavaScript is still the most widely used language, and it's really one of my favorites because it is such a chaotic language, and you know I've been using it almost since it first existed, and I'm still not used to the sort of the prototype model that it uses. I still get things wrong all the time in it. You know, I've seen art students who are still getting somewhat comfortable with code put together JavaScript by going to websites that do something sort of like what they want, taking some JavaScript, putting it together with some other JavaScript, this kind of Frankensteining it together, all this stuff from different sites, and getting something that actually works and does what they want. Even if there's errors all over the place, it's like, oh, this is running. It's you know, like, who cares about these errors? It's doing what I want. This, like, I think that's amazing. That's something that you really can't do so easily with other languages. JavaScript is much more forgiving because it is the language of the web. I'm really not a fan of these frameworks that people put on top of it. I think you know, it's nice that people have things like React, but it makes it so that you can no longer go to a page and sort of view the JavaScript and sort of understand everything that's happening and reusing that stuff. So I really try to stick with vanilla JavaScript as much as possible. And I especially dislike TypeScript. It just feels sort of disrespectful to the language of Eris to sort of force types on top of it and try to get it to function like it's like C# or something. But yeah, I would say that JavaScript is really sort of my favorite programming language, even though it's not the language that I'm best in. One of my languages in the book, so apart from Fatfinger, which we already discussed, I have another JavaScript dialect in the book called Undefined, because one of the great things about JavaScript is that you can, if you want, you can totally avoid having integers or strings or floats in your program. You can build them all with the mysterious value undefined. By manipulating undefined with other, you can transform it into a number. You can add other undefineds that have been turned into numbers to it, and so on, and just manipulate undefined until you get values out of nothingness, which feels very powerful to me.
I love that. Yeah, that might be a perfect place to end. That was great. It was fantastic. Thank you, Daniel, for chatting with me. This has been a great conversation.
Oh, thank you so much.